Hello. Today, let's talk about our heart of our balcony power plant, the solar panels, because this is the heart of our system. And it typically delivers a power between 360 watt and 420 watt. However, we have new solar panels achieve a maximum power up to 650 watt, thanks to bifacial models. Despite its compact size of 2 meter to 120 and 3 centimeter thick, it offers an impressive performance. For the best result, the model should be oriented to the south. Depending on the modular, we get a performance guarantee of 20 up to 30 years by the manufacturer, which makes, of course, these models a long-lasting and sustainable energy generated for our home. Then, of course, we have bifacial solar panels, which can generate up to 25% more energy. These are the relatively new technology on the market. These models use sunlight efficiently on both sides by reflecting the sunlight from the substrate of which the PV models is located, generating up to 25% additional power on the back side of the module. They are really nice, of course. Then, of course, we have the difference between N-type and P-type technology. Because photovoltaic cells comes in two main types, P and N-type. The P-type cells are positively charged because they are doped with boron, which lacks in electrical compared to silicon. This results in a positive charge carriers. In contrast, the N-type cells are negatively charged because they are dependent with phosphorus, which has on the additional electron compared to silicon. This additional electron generates free electrons. The N-type cells, especially type of the TOPC cells, offer several advantages. Their additional free electrons leads to the high efficiency and prevent the power losses, as well as problems such as the PID and the LID. In addition, they can convert direct sunlight into electricity more efficiently. These cells are also more heat resistant, which increases their service life and efficiency compared to the P-type cells. Of course, that means maybe if you can choose, you should choose the N-type cells because they are the most advantaged system on the market. The temperature coefficient describes how the performance of solar panels decreases with the increased temperature, and N-type cells are more robust in this regard. Then, of course, we have PID, potential induction degradation, and LID, light induction degradation. These are two phenomena that can affect the performance of solar panels, but not in N-types. Only this phenomenon can be in the in the P-type technology, solar panels, of course. That means the PID occurs when the voltage difference arises between the silicon of the solar cells and the model frame. This can cause sodium ions or other impurities to migrate, which interferes with the current flow and the effect of the performance of the module. The LID, on the other hand, occurs on the silicon cells due to certain defects. These defects cause the module to suffer a loss of performance in the first hours of the exposure. The impact of the PID can be significantly, with affected models being able to suffer a power loss of more than 30%, while the impact of the LID is not that serious. A model can suffer a power loss of up to 3% in the first few hours after installation. Most of this loss occurs in the first hours, okay? But the big thing here is look for N-type. Then, the second big thing on solar panels is bifacial solar panels. These are innovative in photovoltaics, which can absorb sunlight from both sides. For example, from the front and from the back side, and convert it into the electric energy. The structure and the function behind that is we have bifacial cells. The bifacial solar cells are light-sensitive both on the front and on the back side. The rear side energy generation makes this possible. They are able to absorb the refracted sunlight from the Earth's surface or from the adjusted structure. The power generates depending on the albedo degree of a reflection, which describes the degree of reflection of diffuse reflection, which comes from a not self-luminous surface. That means we can increase the energy models to generate up to 30% more electricity than conventional models. And bifacial models use sunlight more efficiently by absorbing both direct and indirect sunlight. And it's cost-effective solution. Bifacial models are a cost-effective solution because they increase energy efficiency without increasing additional cost for installation. And the durability. Bifacial models are durable and can be used in extreme weather conditions. And of course, environmentally friendly. The bifacial models are environment friendly because they do not release harmful emissions. For example, if you have an assembly on the rooftop, for example, white color is underneath with a good reflection of 60 up to 85%. A performance increase up to 30% is possible. Or we have an Pablo roof or a Pablo, an increase of 15% can be observed. Or concrete, the material allows the additional performance gain to 12%. Grass, 9%, and water, 5%. This can be expected, of course, additionally. In summary, the bifacial solar models are the revolution in solar energy generating. The maximum space utilization through the increase of power per unit area and ensures a longer surface life through the use of the temperature's glass. Especially in areas with a high degrees of reflection, they unfold their full potential and lead to a much more efficient solar energy generating using our balcony solar power system. Thanks for watching. Please subscribe me and give me a positive feedback, and I hope to see you again on my channel. Soon.